confusion, the confusion matrix,
Okay, we are rolling. Welcome back, 8 Hour Weekday. Yes, very good. Hot as the the fourth heat wave of the year hits the UK. Sounds really grand, doesn't it?
Yeah. Well, they're pretty commonplace these days. It reminds me, this type of heat, especially up here in Scotland, it's still nowhere near as hot as you, but it's still pretty hot. It's like a slow cooker, right? You ultimately, it feels like I'm just being basted. And, it's not quite hot enough to fry me. I'm just being slowly cooked, and tenderized. So I'll probably just, flake apart like a pulled pork at some point.
I was going to say, how do you like your Alex? Well done.
Yeah, well, exactly. So flaking apart bit of brisket. I'm not sure, I should be covering myself in like paprika or whatever, and seasoning myself as I go along. At least if I'm going to go out, I might as well go out tasty. You know what I mean?
And with that, get yourself in the news, I imagine. But there we go.
Right. So we have a subject for the day, and it's quite I was just going to say it's quite a meaty one.
Very good.
I like that. Completely unintentional pun. So we want to talk about, I guess, the broader spectrum of the subject is language model testing. And we want to talk today about what we're calling language model QA. But just to differentiate here, the language model QA, in the way that we're going to talk about it, is the job. It is a supply side job of making sure that the models are behaving in the ways that the users would expect them to. It belongs in the realm of, OpenAI or Anthropic or whoever's creating the models, to ensure that, the next model that comes out says the things it's supposed to, does the things it's supposed to. Now that's differentiated against other business who is deploying LLMs either internally or externally. This is the demand side, which is making sure, given what you've been given by Anthropic, say, how can we ensure that model, within the implementation of the job that we have, how can we ensure that's going to give us consistent results, right? What we want to talk about today is the former, which we're calling model QA. So do you want to elucidate a little bit for us what we mean by that?
So really this is all about, as you say, testing the models. But the reason to do the testing is in order to produce data. In the traditional world of software development, programming, everything is deterministic. So you code something and it does what you say. If it does it wrong, you have a bug, and you go back and you change the instruction, and now it does it differently. It does it according to your test. So that's all very good. So that's the traditional approach. With language models, which we'll come on to in a second as to why this is, they are probabilistic in their approach. And so if they get something wrong, it's not because you have a line of code that says, do this, and maybe that's conflicting with another line of code. And so you get, a weird output, which is what most bugs turn out to be. It's because the data that they have doesn't allow them to predict the next chunk in a way which answers the question or the problem in the right manner. So this is where we have to go back to, what are these large language models and why are they probabilistic as opposed to deterministic? And the models are probabilistic. So they are, for want of a better word, guessing the next bit. And this is where we've talked before on this podcast about the language we have as humans is about, we'll say things like, oh, well, they know that they gave me the right answer because they know what they're talking about. But these models don't know anything. They're predicting the next word or the next chunk of words and then checking that against an overall large model.
So just to clarify,
Yeah.
in a deterministic world where you are a Python programmer and you simply have a line of code that says 1 plus 1, right? And you execute that and it's going to give you 2, right? And you know that that's the case. If it isn't, you've got really huge problems and you probably want to reinstall Python and or something. But, 99.9 recurring percent of the time, you should get the answer 2. And it's deterministic. It's just, if it isn't giving you 2, there's a bug, right? Whereas with language models, they don't understand numbers. And I guess we're not here to get sort of caught up in why necessarily they don't understand numbers, but they don't. Therefore, when you ask it 1 plus 1, it might give you 2 because it's seen 1 plus 1 many times before in its training data. But if you give it 1,942 plus 2,633, if it's never seen that, it might make an educated guess and it might even get it right, but it might not, right? Because basically the outcome is non-deterministic, it's stochastic or probabilistic, and therefore we have to be careful when asking him to do such operations. And I think that the numbers example is a very straightforward one, but I think the one you've used loads of times is the tennis one, isn't it?
Yeah. So asking for tennis scores from a couple of years ago when it should be fairly obvious, who won men's final at Wimbledon 2022, what was the score? And it's a bit of a random roll of the dice as to whether it gets the score right. And if it gets that one right, just ask it the semi-final scores and you're into tricky territory.
Well, even getting the winner right, like anyone who vaguely follows like Grand Slam tennis will know that, I don't know, Milosevic or someone won, whatever that was, 2022 Wimbledon. But the model might just make it up. Maybe it was Martina Navratilova. I know like 4 tennis players. And the fact that I managed to come up with Milosevic, which I think is a tennis player, is he?
No, isn't he a dictator from Yugoslavia?
Probably. Slobodan Milosevic. Yeah, I haven't got a clue. I really don't know.
Yeah,
Spanish guy.
Djokovic is probably who you're thinking of.
There you go. All right. God, there you go. I'd like to point out that is just a complete non-interest in tennis rather than any random xenophobic spouting from me. But there you go.
So the point about the 2 ways you fix the different bugs is in programming. You go and you look at your code because your code is controlling your output directly. But of course, many lines of code, it all starts to get a bit hairy and you're not quite sure where you are and things interact in ways which you hadn't necessarily anticipated. And therein we have software bugs and unexpected behavior. But in the models, they're not working from instructions in the same way. They are built from data, and they build up, literally a model of data, and in this case, language, and then they are predicting the next word based on the most likely outcome in that model. And I always think that you explain this quite well with your cheese and ham sandwich example from some years ago when we first started talking to people about language models. And I don't know if you can recall that, but it was always quite good to elucidate how a model knows that ham and cheese might go together in a sandwich, and then also how it might not know that.
Well, I like ham and cheese sandwiches, so I'll quite happily talk about it. I think generally, I think was always trying to illustrate the sort of the topographical or geographical view of the underlying model. And
Yeah.
the effectively you've got cheese as a noun, as a concept, and ham as a noun, as a concept, but you've also got cheese as an adjective, right? As in cheesy music, I guess, or a cheesy film, or a cheesy photograph or something. The model needs to decide context, and so if it sees cheese and ham together, it's likely that it will understand the cheese in that context is it relates to the food stuff, and therefore, if it's writing out a recipe for cheese and ham toasty, it might guess that the next words in the ingredients list was bread, right? But whereas is it seeing cheese on its own, wouldn't necessarily know what to do with that without some other sort of context, i.e., this movie was a big pile of cheese, right? It doesn't know at all that movie wasn't literally made out of cheese. It's that Wallace and Gromit one where they go to the moon and the moon is made of cheese. It does happen, right? It happens. But honestly, it doesn't care. It just knows that the cheese in that context will yield different subsequent words. And I think about this in terms of geography or topography, whereby ultimately every sort of term or word or expression exists in an n-dimensional topographical space, and things that are more closely related exist in that topographical space closer to each other, and therefore the probability of them being related in certain circumstances is high, right? Now, if you saw cheese and ham next to bread, you've got a pile of foodstuffs. If you saw cheese next to Adam Sandler, right, which I can imagine you would, then it's got a different concept and a different place. Adam Sandler occupies a different place in the model's internal topography. And then that's where you can start, if you take the vectors, you can do mathematical operations with them, because they're really just figuring out distance. So if you take two word embeddings, you can take an average of the two, and it gives you a center point, which may, then you can find out the closest word to those two terms. So if it's quite a small semantic space, if you took the average of cheese and ham and it spat out bread, I don't think anyone would be too surprised, right?
Yeah.
And so that's sort of how it works. And I think if you're then thinking about it with ham and cheese, you've probably got, I don't know, mayo or butter or something lurking over there. And with Adam Sandler, you've got Arnold Schwarzenegger, I don't know, whoever you want to call out, the humans, and then perhaps you've got Clark Gable in that general area, but he's quite a bit further away, because actually he's further away in time. He'll be more closely related to, black and white movie stars rather than a much more modern movie star. I was watching an Adam Sandler film last night, which is why he popped into my mind. I got about 5 minutes through it and then turned it off.
Well, which one was it?
I have no idea. It's got Jennifer Aniston in it, and then I sort of realised that they apparently all of them seem to have Jennifer Aniston in it, and therefore, in the model's topographical space, Jennifer Aniston would be very close geographically to Adam Sandler, but also obviously to Matt Perry and all of the Friends people, right?
Yeah, and I think this is really good, and I'm going to push the topographical metaphor here, because I quite like it, because I imagine, as you were talking there, that your ham and cheese, is sitting on, like a mountain, like if you imagine a map now, even a three-dimensional one that has height, like a plasterboard model, like the old days of model trains and all that. And so you got this mountain here, and that's got lots of words in it: ham, cheese, bread, butter, tuna, sweet corn, etc. And then you've got another mountain, maybe reasonably close by, and that's about films, and that's got cheese and your Adam Sandlers and your Jennifer Aniston's in it. And so because you're in a mountain, the ham and cheese, when you're over on that mountain, they're going to be more closely related. So if you're talking about sandwiches, you go to the sandwich mountain and you're in the ballpark. And that's why quite often when these models come back with things and they don't know the exact answer, that's why sometimes it's quite close. Like if you ask for, who won the final of a tennis final, it might give you another name, somebody that was in the semis or at least was in the competition or has won it before, because you're on the tennis mountain and it knows that this guy's on the tennis mountain and it's not far away. So it's saying the highest probability I'm finding is on this mountain. But as you say, with our cheese and the ham, there's another mountain not too far away with cheese on it. And the other thing to remember about these is there is a relation between those two cheeses. So it might be a faint line or maybe a fairly strong line between the mountains. And if the model steps back, it can also see that. And as you say, you then go over to the film mountain where we find Jennifer Aniston, and then there's some links to Matthew Perry and the other guys, and maybe they've not been in so many films, but that goes over to the TV mountain, which is obviously quite close. So there are relations between these things. But when you're on the film mountain, you're more likely to get film results rather than TV results, but you could still get a TV result. You might see that link from Jennifer Aniston to, not Matthew Perry, who's the other one, Joey, who's done less films and more TV, it might make a jump over to him. And so therefore you jump from the film mountain to the TV mountain. And then if you then ask a subsequent question, you might find you're getting more TV answers. And that's, some of the ways these things work.
Now I do like the idea of a mountain of cheese. A mountain of friends characters I get along with. I don't know about like a mountain of eggs or something though. But I like the way that there's all these big food mountains. It makes me want to go into the model. Because what other mountains are in there? Like, you know what I mean? What could you end up climbing up? A mountain of kneecaps. You know what I mean?
Exactly. Well, this is where you and this is quite good because this is where you step into William Gibson and Neuromancer, because he described the data landscape. I think it was mid-80s. That was written 84, 86. And he talks about, in that book, which is a cyberpunk, futuristic, he talks about, jacking in, which is very Neo in the Matrix. I think it was slightly less intrusive. And then visually and in a 3D sort of avatar quite way, a bit like, what was it called? Second Life or First Life, whatever it was. And floating around and then floating through mountains of data. And that he was there. He was a hacker, I think, that was trying to hack in. And they were approaching the corporation's mountain, and so it's kind of, he was clearly quite prescient, and maybe that's what helped gear me up there for a bit for thinking about these things as mountains. But so there we go. Neuromancer and William Gibson, we might finally have arrived.
Well, we have created that topographical connection between cheese and ham toasties and neuro-linguistic hacking as per William Gibson. So that's pretty good. Right?
So there we go. So that's so that is a long prelude, really, to talk about the getting ham and cheese together and it therefore being wrong or right according to what you might expect when asking a question, is not down to a piece of programming saying when you see ham, throw out cheese. It's down to millions of data points which point to the fact that when you build them up into a geographical model, that ham and cheese just happen to occur a lot in the English language, and so they end up being close together, as you say, and therefore this becomes a mathematical thing, and that probability is get me the closest thing to this one.
Well, I mean, you say that they just happen. I think there's something more intrinsic going on here because they are related, right? And,
yes.
And I think that it's easy to look at the underlying models in a fairly flippant and dismissive way because they can make mistakes between mixing up fascist dictators and tennis players. Oh no, that was me. But like, you're like, well, they don't know anything. Well, they don't. But the reality is that that connection exists, right? And if you think about it less in terms of this sort of topographical world, more in terms of a graph as a network, then everything is in some way connected to everything else, and they store a very, very valid, if not highly compressed, version of the semantic substructure of the human world via language, right? Because not only are the words ham and cheese closely related, but as concepts, but they're closely related as being, animal products that are farmed and blah, blah, blah in the real world. And I think that shouldn't be undercut. We shouldn't underestimate just how brilliant that is, that exists.
Yeah.
The problem is that a lot of those links are slightly more tenuous. And if the model is lacking the right degree of context, then it's going to make mistakes.
Yes. And won't just make mistakes on the context, but also the lack of data. And we've all heard that they supposedly have already consumed the internet. And so there's lots of data manufacturing going on to try and sort of plug the gaps.
Well, there's also crap in, crap out, right? So,
yes,
like you can, cheese and ham are closely related, but if there's a group of people out there who particularly like eating cheese and coal instead, or cheese and old shoes, that the model might well assume that those are closely related as well. It's probably a pretty stupid example, but this is where we get stuff like racism, into the mix. Because quite frankly, people out there on the interwebs are being racist. And therefore, the model has learned that there are some particularly disgusting, lines drawn between concepts that should in no world ever have happened. But it knows them; they're there, right? And I think this sort of brings us on to what we're talking about here. Is that, let's not get dragged into the whole sort of models being evil, racist, fascist, or whatever, but just generally getting stuff wrong, which is probably okay in the cheese and ham world, but it's definitely not okay when, used in decision-making context and stuff like that.
Yeah, absolutely. Yeah. And so, to bring it back around to the QA side. So now, the challenge is if you want it to do something different, apart from the roll of the dice of the probabilistic, you need to give it more data. One of the key ways that this has been happening is to give the models, find a problem, if you like. And from a model perspective, that is, okay, ask a question and it came up with the wrong answer, wrong being in inverted commas or less than optimal, as we like to say normally. And then is to show that wrong answer and then also show it the right answer and maybe even start to break it down as to why it might be right or wrong. And so you can start to go down the different axes of, well, what do we mean by rightness? So one, you've got correctness. So as we mentioned, who won tennis? Kyrgios won the 2022 men's final. No, he didn't. He was the runner-up, so he lost. So that's a straightforward correctness issue. You then might have other axes like instruction following. So you ask for the Wimbledon final result and it gives you a full rundown, play-by-play of the actual match. So it's giving you something you really want. So that's wrong, but it's wrong in a different dimension. It might give you the right result, but you just wanted a summary saying, who won it? So you can post it to your mate that it was. And it gave you a 25-line description of every point and,
Well,
and every great
which is a
quality.
pretty common occurrence, the models being overzealous. And let's just be clear about what we're saying here. The Model X regularly classifies cheese as a fruit, which in my mind it should be. Like if you've got like an Edam, that almost looks like a big red melon. You know what I mean? Anyway, cheese is not a fruit in anyone else's world but mine. It's wrong. That is wrong. But your model consistently classifies it as a fruit. And what we want to do here is, it's not a great example, it's quite a facile example, but what we want to do is take the model and reinforce correct concept. So what we can't do is look into the model and as you would with code, where you've got an if else statement, and in there was an if else statement. So if it's spherical and red, it's going to be fruit because it's an apple. Well, that's just a bug in the code, right? What you want to say is some extra Boolean logic in there. Is it's spherical and red and has a wax coating, it's probably cheese because it's Edam. If it doesn't, it's probably an apple, right? And therefore, in the deterministic world, you compare straight into the code and go, there's the issue there. We just missed out a clause. Let's put that in. It's a simple bug, right? Now, we can't peer into the models because they're just big, gigantic fields of just mathematical data, right? Just bits and bytes, right?
Yeah.
So if you want to correct the cheese as a fruit problem, you have to convince the model, to use an anthropomorphic term, you have to retrain the model to make the correct connection there, which can be done, I guess, in a sense, by taking your training data itself and just hunting through and finding all references to cheese as a fruit. But it might not be that obvious. It might have learned that wrong connection via some more abstract route, right? Or just a probabilistic fuck up somewhere, right?
Yeah.
Therefore, you would want to sort of override the knowledge. And it's no different as if you pulled me up one day, Alex, you keep on calling cheese a fruit, it's not right. I would disagree with you vociferously, but if every time I called it a fruit, you corrected me, I would probably eventually find it very hard to call it something else. But I do stand by it. And little mini baby bells are like a little grape, and then you've got like a whole Edam, which is like a melon. They're fruits, mate.
Exactly.
You can't tell me otherwise, right?
Yeah.
So
yes, it's exactly right. Add in more right things rather than trying to remove the wrong things. I'm sure there's some removal that goes on, and then, as you say, explain why it's wrong. And this sort of, I think, plays forward into a little bit more into the reasoning models, because they have these things that are called reasoning traces. And that's really down to, well, here's the wrong answer. It's wrong for these reasons. Here's the right answer, and it's right for these reasons. So you're giving it effectively more data that it can then base future reasoning on.
So let's just be clear on the distinction there. Cheese is a fruit. So we're going to retrain the model by putting in where we see it stated as a fruit, we can sort of send a negative signal into the model. It's sort of binary, right? Wrong, right? And or send a positive signal in there. Cheese is what is cheese? Cheese isn't a fruit, but what is it? Cheese is a cheese.
It's a dairy product.
Dairy products. There we go. See, I'm so ingrained with the fruit thing now, I can't even remember what cheese actually is. So, but we're sending sort of simple one-shot adjustments. I think the reality is probably a little bit more complicated than this. But for the sake of this conversation, we're just saying no, wrong, or yes, right, right, which is a bit more like traditional machine learning, right? Where you want to, whether you want
Yes.
to write a classifier effectively, yes, no, yes, no, yes, no, yes, right?
Yeah.
Showing it pictures of cheeses and fruits and just saying cheese, fruit, cheese, fruit, cheese, fruit, right? And,
Yeah.
but what you're saying is in the world of the reasoning models, not only, I'm assuming you can still do that, but you also have this method of saying, well, no, it's not a fruit, and here's why. It looks like a fruit, but it's covered in wax. It's made of milk, and fruits are never made of milk, and probably some are covered in wax. I don't know, but you are literally talking about bringing up a text box and saying, no, mate, soz, it's not a fruit because X, Y, Z, right?
Mhm.
And that's the actual action you're taking at that point as the person evaluating the model.
Yeah, exactly. And so there are recognized, I think there's I think it came out of machine learning, but there's a recognized number of sort of categories, like I was mentioning, that you can, say it's right or wrong. So, correctness, instruction following, things like verbosity. Is it too long? Is it too short? Is it too brief? And there are a number of these, and you can sort of rate them, and you tend to rate them on a sort of a 1 to 3 scale. So it's definitely way wrong. It's a little bit wrong, or it's
Right.
okay.
I think you said a few more things there that are worth pulling apart here, right? So cheese is not a fruit. Here's why cheese is not a fruit. So what you're doing there is correcting something that's wrong, right? But you could say, qualitatively, Edam and Gouda aren't the same cheese, or an apple and a melon, or a Granny Smith versus I don't know, whatever the big red apples are. These are apples. They are fruits, but they're not the same, right? And so there's a more of a qualitative aspect here too, right? So flat wrong, cheese is not a fruit, but Edam is not like Roquefort. They're very different substances, even if they're derived the same way. And so one answer is flat wrong. The other answer is a bit more nuanced, right? And so
Yes.
you can almost say, well, yes, okay, you called it fruit. No, really wrong. So 0 points. Versus you said it's a cheese like Roquefort. Well, okay, you're all right. Maybe that's a 5, right? But if you said it was a cheese like Gouda, you're probably in the 10 territory, right? If this is out of 10. Is that what we're saying?
Yes. And I'm going to add another layer in, which makes it slightly more, more nuanced and possibly confusing, in that you tend to be always comparing one with another. So you rarely are saying, here's, you said as a model, we asked you this question, you said Edam was a fruit. What you're generally saying is, we asked the same question to 2 models. Model A said it was a fruit. Model B said it was a cheese. And so that the rating is then a comparative rating, because what you're then giving to the model is, here's a wrong answer and here's a right answer, and here's how much brighter it was. And those comparisons, go from, they're roughly similar. One is slightly better than the other, one is better than the other, and one is enormously better than the other.
But
So
they might both be crap, right? They might both have said,
yes,
Edam was a fruit, cheese was a fruit.
yes. And again, and so this is where we're getting into the kind of subjective territory, because you could have them both saying that they were fruit, but in your example of comparing another cheese, so one might then say, and it's really close to Roquefort, and you go, well, that's definitely wrong. The other one says, it's quite close to, I don't know, Emmental, which maybe is better. So you'd say, well, the one that said Emmental is definitely better because we're in hard cheese territory there. But the Roquefort one's miles away. So even though they're both wrong, one is slightly less wrong. So this is where it comes into the use of the word optimal. So when you do that comparison, you'll say, oh, well, A and B are both wrong, but B is still better than A. So it's, it's getting multiple indicators there. Plus you're into the world of optimal answers and better answers, not necessarily right answers. So this is where, you end up with a sort of full spectrum.
Well, so
as you say,
a real world analogy for me, the one that jumped to mind would be Prime Minister Keir Starmer said something, right? Something about cheese, in fact. He said that cheese is a fruit. Now, the way that that's going to get reported in the Daily Mail versus the way that's going to get reported in The Guardian are fundamentally different, right? What they're both going to say, Prime Minister Keir Starmer said today that cheese was a fruit. They're both going to say that. But their interpretation, their reporting, the way that the words they choose, the way they chose to tell that story, literally that story, is going to be totally different. And the moral that they'll come out with, so the Daily Mail was going,
"The stupid bastard couldn't even tell the difference between a cheese and a fruit."
Whereas the Guardian might be more sympathetic.
He was clearly making a point about language models and their tendency to get things wrong sometimes.
There definitely is two sets of opinions, and depending on who you're talking to, both opinions could be valid, even though the Guardian reader might snort at the Mail article and vice versa. Strictly speaking, they're probably both correct, depending on the context, right? And so I think that there's a mountain of nuance that needs to be accounted for, right, in terms of training models.
Yes, exactly. And it's that nuance that this judging the models in these ways and effectively giving them feedback, which is essentially then creating new data, which then gets fed in on the next training cycle. And then obviously what you're hoping for is the new data that gives it, all these different comparisons of cheese as a fruit and Roquefort and Edam and Emmental. And hopefully you give it enough that after the next round of training, it sees its mistake. And so when it produces the answer, it realizes it's not a fruit and comes out with the better answer that it's a dairy product and it's close to, or in the same family as Emmental or cheddar or something rather than Roquefort.
You've contextualized it, really. And so I think we need to come back a little bit to the reasoning here, but back to the sort of Keir Starmer being represented differently realm. Given that both those responses were correct, if you typed into ChatGPT, tell me about the cheese speech with Keir Starmer yesterday, it's got to choose where to land that. But had you and me I'll be the Daily Mail reader. I don't want to insult you, and you can be the Guardian reader. Maybe being a Guardian reader is insulting too. But had we had some upstream conversation that clearly, labelled us as a liberal versus someone who's more conservative, it might well choose the Daily Mail interpretation for me and the Guardian interpretation for you.
Well, absolutely. Yes.
Can I just point out that I don't read any of the Daily Mail's output, be it online or in the paper version. But I also don't read the Guardian either, so I don't know where that puts me.
Very good. Yeah. So, and I think there's probably almost a point to segue over to how the learnings that you can get from doing this and how that goes over to the demand side. But it's just one more thing I wanted to mention. There's been a move as the year has gone on away from the ratings to providing very detailed rubrics, as they're known, created for a prompt and the response. And these are being used to specifically rate models against, the prompt and response pair. So just to expand on what I mean by that. So you give a prompt, which could include a system prompt as well. So you're saying, oh, right, you're an AI assistant and you are helping me to look at pictures and describe what's in them, because we're doing something for the sight impaired for websites. So we've got a bunch of images, and then you'll output that in a JSON format, and then you give it an image, and the model takes a look at it and says, okay, and it lists the things out, and you're like, all right, you missed 4 things there. What you then do is you create a number of rubrics which are specific, one at a time instructions. So it's going to be saying, one of them, the first one's going to be you will receive pictures and you identify items within a picture. And the next one's going to be you output JSON, and then you output this and you output that. And then very specifically for that picture, you'll say, does the response output an orange as one of the items? Does it output an apple as one of the items? Does it output Edam cheese as one of the items, because that happened to be in the picture? And that then list can be used, so you can then throw the same prompt at a number of other models, and then you can use this set of rubrics to actually judge whether these other models got them right. And that's really picked up in the last few months. And so that's obviously been seen as a sweet spot, I reckon, for the retraining, because a lot of stuff is moving that way. And so you're having to create these judgments, which again are much more detailed. That means you can then measure models specifically whether they got A and B wrong. And from that, I'm guessing that, more data can then be manufactured. So I'm imagining that this also goes into synthetically building more data.
That's really interesting. I had to look up what asked Ada what rubric meant.
Indeed.
Because it's a word I basically feel like I've heard, but I didn't know what it meant. Unless, you misspell it and you've got a Rubik's Cube.
A rubric is basically a guide or a matrix used for assessing or grading work, usually in education. It lays out criteria and standards so everyone's on the same page about what's good, mediocre, or utter arse. As for the origin, the word rubric derives from the Latin rubrica, meaning red ochre or red chalk. Back in medieval times, scribes wrote titles or instructions in red ink, literally rubrics, to separate them from the main text. Over time, that evolved metaphorically into a heading, direction, or standard.
Which is really exactly what you just said.
That feels like school.
It really does. And so effectively, you're given some output and you're creating a set of instructions or steps to get from A to B. And that could be in the English language, or it could be code or whatever. And so, I guess I'd sort of think about it like, if there was a certain coding algorithm, right, that it's just not very well represented out there in the web. The data set doesn't contain much of it. That you could want to write that in multiple different languages, and write down the sort of pseudocode logic and the assumptions and all of this stuff, and feed that into the model just so it fills in that blank, right?
Yes.
And to be much more explicit. And so it could be filling a blank, or it could be correcting sort of an incorrect assumption that's been made about, something or other. In fact, could be, where does the word rubric come from? And maybe it just has a wrong, a sort of incorrect line of reasoning on how to get to that. It thought it came from Old Norse as opposed to Latin or something, right?
And that's backed up, especially for code, which, we again talked about before, which is if you want the model to write you some code of which, there are likely several billion examples. So, what we call boilerplate code. So, I'm trying to create a pedantic model, or even in Python, it's quite good if you give it, write me a function that does X. and here are the parameters I'm passing. It's really good at going, okay, well, here are the parameters you're getting in. You want me to do X? All right, well, I'll do that with these, because it's finding the other examples similar to that and throwing it out. So it's not too bad at that. And especially if you give it someone, I want to create, a decision tree, machine learning model. It's going to go to sklearn or one of the Google platform learning. It's going to bring in all the code and it's boilerplate, because there are tons of these examples. These libraries are written so that everyone's pulling in the same code. There's starter code, there's examples. It's pulling that in and doing it for you. And you go, oh, that's really good. Because that would take me at least, 2 hours to get all that up, because I've written it for 6 months and I know it's possible, and it does it in a matter of seconds. But if you're into an actual specific coding problem where you're, I don't know, trying to work out what our sales for this company are down and got these costs and this and that and the other, and you're putting these together, and you want it to produce a function which is adding these up, taking that away, and you ask it to do it, it comes back the whole load of nonsense. Why? Because it's gone to a mountain that hasn't got much on it. And so it's looking around, and it's just kind of grabbing some other stuff that was there, and then it's reaching across to the other mountain and putting in some boilerplate code. And then you look at it and you go, yeah, but this isn't, this is my specific problem, probably been solved, but it's been solved for other people in different ways and with different language in different contexts.
You know what this is? This is the teach a man to fish problem, right? So you can say, here's the canonical way to add two numbers together in a function in Python or Java or whatever. And all it can do with that is sort of recite it by rote. But if you give it a reasoning path from nothing to something, and other examples of doing similar things, it can make those jumps more easily, right? So you're filling in some of the blanks, but you're also saying, well, no, this isn't, I don't need to tell you that if you want to, write more functions that add numbers together, I have to write out every possible function that could be done like that could be used for that. That would be ridiculous. So, it's adding numbers together is a really bad example, but if it was something much more, if there wasn't many examples of the Fibonacci function out there, perhaps.
Exactly.
You know what I mean? That
Yes.
you would explain why it did it that way. And then when it comes up against another similar problem, it can make that it's a little jump rather than a big leap.
Exactly. And so, you can really see how, why that appears. And and in coding, you really do get that. Great for boilerplate, great for getting you started, not so good when you're in the depth and you've actually got a specific problem that you're trying to solve. Generally, they're not very helpful. So this is where like you say, you have to start, looking underneath the stuff you've learned and start looking at the principles of what you've learned and applying those principles to a brand new problem.
Well, it's like teaching kids, right? And ultimately, you do your times tables. You know what I mean? A 2, 4, 6, 8, 10, 12. You've got a rote learning there. But if you teach the kids, here's a little heuristic. Here's how to think about how to get to the next sequence in the times table. And so we're in a world where, really what we've said here is that training language models is becoming increasingly like teaching humans, right?
And if you think about, if you add some empathy in there, then you start to look at the mistakes rather than, oh, you got it wrong, Harum. Why have you got it wrong? As to more, like you would with the child, well, you got it wrong. Well, why have you got it wrong? That's interesting. Like, how can I help you get it right? And I think we've both been through this journey, probably like most people do, where you just get hacked off with getting the wrong thing. But actually, if you put some thought in it and you think about how can I get it to give me the right thing, that's a much more productive path.
Yeah, it's the even better if scenario. Whereas, so you ask a kid, what's 4 times 2, that kid could write out 2 plus 2 plus 2. Whereas there are, more straightforward and direct ways to do it, either on paper or, in your head, right? And it really is even better if. Now, you're not wrong, you know what I mean? And it's probably not a good example if it was, 20 times 2, right? And they'd written out 2 plus 2 plus 2 plus 2 plus 2. That's not wrong. You are spot on, but there are more efficient ways of doing this if you think about it this way, right? And so I think this is not just about correcting things that are wrong. It's about teaching more efficient ways to do things.
Yeah, more efficient and understanding that the way you're explaining it, might not be most optimal for the machine that's trying to understand you. And I think you've been down this path fairly recently, with the vibe coding and everything. Is if it's doing something that you don't want it to do, then adjust what you're telling it to do. Why not use the machine, which knows what it wants, to get it to write its own prompt and then, adjust from there. And so it becomes much more iterative to nudge it in the right direction rather than just binary right, wrong. Now there is a limit to that, and having, tested a lot of these models, I mean, sometimes it's just nice just to go, oh yeah, it's wrong. Let's try again. I got it wrong again. Then let's say I got it wrong again. And I think this is where we start to bleed over into the demand side, because that's a lot more, the demand side, as we talked about it, traditional code. I've got a system now contains an LLM in the mix, but I want that system to, if I put in A, I want to get C out, with a mixture of B. But if it's not doing that, I can't just go in and, change the code and get it to come out with it every time. It needs to be some coercing here, which might be thinking about, well, if it doesn't come out with C, how bad is that? Are there some interim steps I can introduce, et cetera, et cetera. So you're into, the mindset should be, one of how can I, nudge in the right direction rather than it's right or wrong.
Yes. So we'll do the demand side another day.
For sure.
Because it's quite a big subject in its own right. And we've been talking about cheese so much. I feel like I need to go and eat. This has also reminded me, I heard on a podcast the other day, someone's talking about sort of correcting bad behavior in the workplace. And, you need to pull people up once or twice. And once you've sort of pulled them up a few times, you'll generally be able to sort of correct the behavior. And the phrase she used was, it's like machine learning, right? It's like machine learning. You just keep correcting it and eventually it will get it right. And I just thought this was the funniest thing, because machine learning is based on humans' brains, right? Particularly the most modern types of this stuff. But, in general, even the sort of the more traditional styles of machine learning are basically derived from what we understand about Pavlov's dogs and shit, right? Right. So we've got this point where someone is using machine learning as an analogy for how the human brain works, right? Which I was just like sent off a recursion in my brain, which almost caused me to blow a fuse, because I was like, that's really, really wild. And it's not like this person was like a data scientist or a programmer or something. She was just an entertainment podcast, right? And it's like, why have you made that analogy? It's bizarre. I just thought it was really, really good. It really made me laugh. And I wonder how very few people would have noted that particular oddity while they're listening to it. But I thought that was quite good, that we've come almost full circle now. We're getting to the point where humans are being, human behavior is being compared and analogized to AIs. right? I mean, that's quite a dark, scary place.
Well, we're going to be into the recursion soon, where we find out that as we build more and more advanced AI, the best way to build them is to build them into organic matter, because it holds everything much better. And then we realize that our ancestors were actually robots, and their fossilization is obviously silicon, which we were never looking for, and that actually we're a race that was we're the robots of the robots, and now we've got all full circle. We've reinvented.
All of this was very much cleared up quite a long time ago. The mice are in charge. We are just part of a big software algorithm on the greatest computer that was ever built, and
Exactly.
and that's a done deal. I don't think it's worthy of discussion anymore. So yeah, there you go. We're all living a
Yes.
simulation. I think we're done for today.
Well,
I have to
we'll
go.
be
This
back.
is what we learned today. We've learned that cheese is a fruit. Remember that, people. Remember, I will be testing you.
Indeed. Well, have a good one, and see you next time.
See ya.
The confusion matrix. Confusion.